Picture a lump of rock about the size of a potato. Now pack it with some of the most valuable metals on Earth.
Beneath the vast, silent expanse of the Pacific Ocean lies a resource sparking one of the most urgent debates in science and industry today: polymetallic nodules. These potato-sized mineral deposits, scattered across the ocean floor, are rich in critical metals like cobalt, nickel, and rare earth elements, all vital for clean energy technologies. But what's less known, and far more startling, is their potential role in producing oxygen. Here's the thing. This dark oxygen, instead of being produced by plants and sunlight, is being produced by strange potato-shaped metallic lumps found on the deep sea floor. It turns out that these lumps, otherwise known as polymetallic nodules, give off almost as much electricity as AA batteries. By reacting with salt water, their electrical charge produces oxygen way down there on the seabed of the deep ocean through a process known as seawater electrolysis, which splits seawater into hydrogen and oxygen. You see, these nodules, which have the potential to save our planet from global warming and climate change since they can be used to produce clean energy, also have the potential to destroy our planet. What you may not know is that recent scientific studies suggest that the microbial communities surrounding these nodules may contribute meaningfully to oxygen generation and carbon cycling, functions essential to the health of marine ecosystems and potentially, the planet. What this tells us is that these potato-sized nodules might be the reason for the existence of the majority, if not all, of the marine ecosystem. And you know what this means to these ecosystems and all of us if those nodules were to be harvested? I bet something far more devastating than global warming could be waiting for us. There has been a heated debate recently between science and industry on whether these nodules should be harvested. On one hand, we want to keep the marine ecosystem alive. On the other hand, we want to save our planet from global warming. For the industry, it's not just about saving our planet because the quantity of these nodules can drive technology way ahead of its time, given the fact that these metals are key drivers in modern technology. The value, a staggering $16 trillion worth of resources lying on the ocean bed, more reasons why nobody would want to give up. But despite all these, scientists warn of catastrophic, irreversible damage to ecosystems we barely understand, and they are right in some way. Remember, we know more about the surface of the Moon and Mars than our ocean floor. What if these nodules are not just responsible for the production of oxygen in the marine ecosystem, but the planet itself? What if, instead of trying to save our planet, we trigger a global extinction? Today we dive into this escalating tension, a clash of discovery and demand, of environmental stewardship and industrial ambition. To ask, can we afford to harvest the seabed, if it means sacrificing the lungs of the ocean? The discovery. At a depth of 4,000 meters or 2.5 miles, pressure could instantly crush a submarine. This zone, called the Clarion-Clipperton Zone or CCZ, looks like an underwater desert. It stretches across 1.7 million square miles of the Pacific, a huge flat area of the seafloor that stretches between Hawaii and Mexico. Back in the late 1960s, a Soviet submarine carrying nuclear weapons mysteriously sank somewhere in the Pacific Ocean. The Soviets couldn't recover it, but the United States saw a major opportunity. The CIA quickly stepped in, launching a top-secret mission called Project Azorian, to find and retrieve the sunken sub. To keep the real mission hidden, the CIA needed a convincing cover story. They claimed they were starting a deep-sea mining operation. To support this lie, billionaire Howard Hughes helped design and build a massive ship named the Glamour Explorer. On the surface, it looked like a state-of-the-art mining vessel. In reality, its only job was to search the deep ocean for the missing submarine. After months of searching, the crew finally located the wreckage in March 1974. But during the operation, they stumbled upon something completely unexpected. The ocean floor was littered with strange, metallic stones. These were polymetallic nodules, small rock-like formations rich in valuable metals like cobalt, nickel, and manganese. To keep up appearances, the team began studying the nodules. What they discovered shocked them. These weren't ordinary rocks. Each one had taken hundreds of millions of years to grow, slowly forming over time. They spread across the seabed in vast fields, billions of them connected through the salty ocean water. They worked like a massive underwater battery. What was even more surprising was their energy potential. Each nodule produced a small amount of electricity, about a volt. Alone, that's not much. A 2016 research study made by Peterson S. and his team shows that the Clarion-Clipperton Zone, CCZ, of the Pacific Ocean hosts approximately 21 billion dry metric tons of potato-sized polymetallic nodules on its abyssal seafloor. This is one of the world's largest known undeveloped deposits of critical metals. Over 6 billion dry metric tons of manganese, nickel, copper, and cobalt are contained in these nodules, which largely lie on the seafloor unattached and are capable of producing up to 20,000 kilowatts of electricity. This discovery, however, was never made public by the CIA. While the world believed it was just a mining project, the reality was far stranger and potentially far more important, and they had their reasons for keeping it classified. It's very clear these metal-rich rocks aren't just valuable for their minerals, they also carry unusual electromagnetic properties. Scientists believe they could be used in advanced power systems, military technologies, and perhaps even in ways we don't yet fully understand, like manipulating gravity itself. Well, that's their story. Fast forward to today. All of us know that plants use sunlight to make oxygen through a process called photosynthesis. But did you know that oxygen can also be made in total darkness? This surprising process is called dark oxygen. It happens deep in the ocean, far below where sunlight can reach. In 2013, Andrew Sweetman, a scientist from the Scottish Association for Marine Science, noticed something unusual. Oxygen was being created at the bottom of the Pacific Ocean, even though no light was present. This discovery led to further research, and in a recent Nature Geoscience study, scientists revealed that metal-rich nodules found on the seafloor are responsible. These nodules slowly form over millions of years from minerals and seawater sticking to things like shell fragments. What's amazing is that each nodule carries a tiny electric charge strong enough to split seawater into hydrogen and oxygen, a process known as seawater electrolysis. This is how dark oxygen is made, without any help from sunlight or photosynthesis. This was a huge surprise to the scientific community, which long held the belief that oxygen can only be produced by sunlight. But now, this discovery was not made on land, it was made at the bottom of the ocean we know little about. For scientists to know fully about these mechanisms and the implications of such activity, they need to study these nodules in different ways. But you see, the recent clashes with mining companies won't create that time, as some companies have started acquiring a license to begin operation. The clash. Earth is unlike any other planet in our solar system due to its distinctive characteristics. But the truth is that, despite all these, there are many we are still getting to know. Our planet is gradually losing its features due to a vast array of human activities and degradation. While scientists keep sounding the alarm on climate change, they also talk about protecting the ocean ecosystem. And we have to solve both issues. You see, what lies at the bottom of the ocean is something capable of changing nations from rags to riches, and to make a decision is now. Most mining companies that carry out surface mining have spotted serious concerns about environmental destruction in most mining regions. They pointed out that deep mining on land can lead to severe risks in aspects like earthquakes and landslides. So, they think deep sea would be the best option to replace surface mining. A Canadian mining company called TMC is one of the major companies that are involved in the Pacific Ocean's deep sea mine. TMC has highlighted Indonesia in discussions about the environmental impacts of traditional mining. The company's CEO, Gerard Barron, has contrasted the ecological footprint of land-based nickel mining in Indonesia's biodiverse rainforests with the potential lower impact of deep-sea mining. He argues that extracting minerals from the ocean floor could be less destructive than terrestrial mining practices currently employed in regions like Indonesia. The truth is, while TMC emphasizes the potential environmental benefits of deep-sea mining, the practice remains controversial. Environmentalists and scientists express concerns about the unknown impacts on deep-sea ecosystems, many of which are not yet fully understood. More to that, minerals like copper, nickel, manganese, zinc, lithium, and cobalt are also hydrothermal vents deposits, which are the main raw materials for smartphones, wind turbines, solar panels, and electric storage batteries. Global demand for these minerals has spiked while supplies from terrestrial mining remain finite and hostage to geopolitical wrangling. For instance, demand for nickel currently sits at 2 million tons a year, and is expected to rise to 4 million by the end of the next decade. Experts estimate that land-based mineral resources might only be available for another 40 years, pushing companies to look beneath the ocean floor for future supplies. Several countries, including China, the UK, France, India, Germany, Russia, and Belgium, have been approved by the International Seabed Authority (ISA) to explore the deep sea for minerals. Of these, China controls the largest exploration zone, covering approximately 161,210 square kilometers, while the UK follows with about 133,280 square kilometers of approved territory. Many scientists and environmental organizations have strongly opposed seabed mining, warning that it could cause massive harm to ocean life and fragile ecosystems. On the other hand, the International Seabed Authority (ISA) remains hopeful, suggesting that emerging technologies could help reduce the environmental damage. A recent Greenpeace report warns that deep-sea mining could cause serious and possibly irreversible damage to marine ecosystems, with effects that might stretch far beyond the areas being mined. One of the biggest concerns is its impact on climate change. The ocean floor stores what scientists call blue carbon, carbon absorbed by marine organisms and carried to the seabed when they die. According to the report, mining could disturb these deep-sea sediments and release stored carbon back into the environment, making global warming even worse. In addition, the mining machines will stir up the seafloor, creating clouds of sediment, called plumes, that can smother life over vast distances. Besides removing key habitats, this process may also release toxic substances, changing the chemical balance of deep ocean waters. According to the report, surface ships used in deep-sea mining operations could release harmful chemicals into the water, putting marine life at risk across distances of hundreds or even thousands of kilometers. It also warns that the constant noise from machinery could disturb or injure marine mammals like whales, and that bright artificial lights used in the deep ocean might permanently disrupt species that are adapted to near-total darkness. In response, Michael Lodge, Secretary General of the International Seabed Authority (ISA), pushed back against what he sees as exaggerated fears. He argued that it's inaccurate to assume deep-sea mining will automatically lead to irreversible damage or ecosystem collapse. Lodge emphasized that strict environmental safeguards are in place, including the use of proven management tools, such as environmental impact assessments, continuous monitoring, and modern technologies designed to reduce harm. He also noted that while 29 exploratory licenses have been issued, these areas account for only a tiny fraction of the ocean floor. The International Seabed Authority (ISA) has been working on finalizing environmental regulations for deep-sea mining, with a target completion date set for July 2025. This timeline was established following a roadmap agreed upon by ISA member states in July 2023. However, the process faces significant challenges. A study published in January 2024 identified over 30 major unresolved issues in the draft regulations, including how environmental impacts will be monitored and assessed. Given these complexities, some observers express skepticism about meeting the July 2025 deadline. So, whatever decision that would be taken then would be the final say about this ecosystem. Well, that's it for today's video. Whatever might be the case, feel free to like and subscribe. And make sure you leave your thoughts on this issue.